Everyone, and welcome to the quadratics unit. We're going to be dealing with a lot of polynomials this chapter. A lot of them have x squared, and that's the definition of a quadratic. In this first lesson, we're going to talk about multiplying polynomials and factoring polynomials. But before we start this unit, I want you to reflect. What have you seen in the past? If I ask you about these four topics, are you confident about them? Do you have questions? Maybe they're brand new to you. They probably shouldn't be brand new to you, but if they are, we'll still learn them this chapter. So take a minute, pause the video, fill out this chart. How comfortable are you feeling with each of these four skills? Okay, so now you know where you're starting from. That tells you which lessons you need to ask questions about, where we need to firm up our knowledge, and maybe we get started at the basics with some of them. Today we're going to start with multiplying and factoring polynomials. So today I can multiply and factor polynomials. That's our goal by the end of this lesson. Now first we got to talk about some vocabulary. So a polynomial, okay, has a prefix poly, which means many, and nomial. Okay, if you've taken Spanish, you know the word nombre means name. So polynomial means many names or many terms. So it's an expression with x squareds and x's and constants. Maybe it has x cubed. Okay, generally we stay with one variable. Eventually you get to multivariable polynomials where you have x's and y's, but for right now we'll generally deal with terms of x. Now multiplying polynomials, we're taking two polynomials and combining them. We're going to use some different methods. And factoring is when we take a single polynomial and write it as the product of two polynomials. So we're going to go back and forth based on which type we need. Do we need it in factored form, or do we want it in one giant polynomial expression? So before we get into polynomials, let's look at this. Let's look at an area model. This is going to be really helpful to understand why polynomials work the way they do. So I laid out a floor plan of the house, and my question to you is, what's the total area of this whole house? The hallway, the bath, the living room, and the bedroom. Pause the video, go ahead, figure it out, and then I'll show you how I did it. So there's multiple different ways we can look at this problem. The first way I liked is I saw, well, area is length times width. So the area of the hallway is 21 times 5, which is a 105. I can do that for every room. And then the area is all of the space inside, so I can add them up. So I take 105 plus 40 plus 273 plus 104. And I can get that the area is 522 square feet. Now I also know that the area of a space, especially if it's a rectangle, is length times width. So length is this 21 and 8, and the width is 5 and 13. So I can do 5 plus 13 to get 18, and multiply that by the length, which is 29, and I can also get 522. So I can add up the inside, or I can multiply length times width. Both ways I get the area. And that's going to help us when we use one of the methods we're going to learn with multiplying polynomials. But before we begin multiplying polynomials, what do you know? I want you to recall what methods have you been taught in the past, and what's your preferred method? If you have one that you like and it always works, I want you to use that one. I'm about to show you two different methods. Okay, I'm going to show you the FOIL method and the box method. Now, I'm not here to make you use a different method. I'm here to firm up whichever method you want to use. So FOIL stands for first, outside, inside, last. It's a way just to multiply, make sure that every term gets multiplied by every other term. So the x gets multiplied by the x gets multiplied by the -3, the 7 gets multiplied by the x, and the 7 gets multiplied by the -3. Now that's the FOIL method, where you multiply, do each one of those multiplications, you add the common terms, the like terms, and then you have an expression. And the box method does the same thing. It just organizes it so you don't forget to accidentally multiply something. It still shows you 4 different multiplications, and it gets you your 4 terms inside the box. Now, either way, you get x squared plus 7x plus 3x minus 21. Okay, you combine the 7x and the 3x to get 10x, and that's how you multiply polynomials. Now, this is a binomial times a binomial because it's 2 terms times 2 terms. We can make this box or this FOIL as big as need be. If there's more terms, you do more multiplication, and at the end you still combine your terms to get a nice simplified expression. So here's some for you to try. Pause the video, take 5, take 10 minutes, try them out, see which ones you can do. Maybe there's one you're stuck on and you have a question, but pause the video, make an attempt. Okay, so here's some answers. Okay, this first one looks nice and, for lack of a better word, normal. It's a binomial times a binomial, so a FOIL works nicely on this. The second one, it's a single term called a monomial times a binomial, just distributive property. You can make the box or FOIL, just make sure the 2x gets multiplied by both terms. This one we got a trinomial multiplied by a binomial. So if you have a box, you should have 6 spaces inside, or if you're going to FOIL, you should have 6 lines. Anyhow, we still combine like terms. It's going to still show up the same way. Now this one always gets to be interesting. For this one, pick a pair, multiply, and then take that expression. So that expression, if I did it, was x squared plus 2x plus 1. And then you multiply that by 3x plus 5. Don't try multiplying all 3 at once. It doesn't work. Or if it does work, it just seems really complicated. So now you should ask yourselves, are you sure I can do these? Is there one I'm not sure of? Maybe it's this one. Now you know the shortcut or a better process to do it. And we'll continue to practice these.